Good morning, everyone. Today I'm going to read the chapter that is corrosion and passivity. These are the topics from the chapter. So let's read. What is corrosion of metals? When metals are exposed to atmospheric conditions, they react with air or water in the environment to form undesirable compounds, usually oxides. This process is called corrosion. Almost all metals, except the least reactive metals such as gold, platinum, and palladium, are attacked by environment, that is undergo corrosion. For example, silver tarnishes, copper develops a green coating, lead and stainless steel lose their luster due to the corrosion. Corrosion causes enormous damage to buildings, bridges, ships, and many other articles made of iron. Thus, corrosion is a process of deterioration of a metal as a result of its reaction with air and water surrounding it. In case of iron, corrosion is called rusting. Chemically, rust is hydrated form of ferric oxide Fe2O3.XH2O. Rusting of iron is generally caused by moisture, carbon dioxide, and oxygen present in the air. It has been observed that rusting takes place only when iron is in contact with moisture air. Iron does not rust in dry air or in vacuum. Factors which affect corrosion. The main factors which affect corrosion are: first, position of metals in EMF series. The reactivity of metals depend upon the position in the electrochemical series. More the reactivity of metal, the more will be the possibility of the metal getting corroded. Second, presence of impurities in metals. The impurities help in setting up voltaic cells, which increases the speeds of corrosion. Third, presence of electrolytes. Presence of electrolytes in water also increases the rate of corrosion. For example, corrosion of iron in seawater takes place to larger extent than in distilled water. Fourth, presence of carbon dioxide in water. Presence of carbon dioxide in natural water increases rusting of iron. Water containing carbon dioxide acts as an electrolyte and increases the flow of electrons from one place to another. Fifth, presence of protective coatings. When the iron surface is coated with layers of metals more active than iron, then the rate of corrosion is retarded. For example, coating of zinc on iron prevents rusting. Mechanism of rusting iron. Electrochemical theory of rusting. The phenomena of corrosion can be explained with the help of electrochemical theory, which involves oxidation and reduction reactions. According to electrochemical theory of corrosion, it is believed that non-uniform surface of metal or impurities present in iron behave like small electric cells called corrosion couples in the presence of water containing dissolved oxygen or carbon dioxide. A film of moisture with dissolved carbon dioxide constitutes electrolytic solution covering the metal surface at various places. The schematic representation of the mechanism of rusting of iron is shown. In the small electrolytic cells, pure iron acts as anode while cathode are impure portions. The overall rusting involves the following steps. Oxidation occurs at the anodes of each electrochemical cell. Therefore, at each anode, neutral iron atom are oxidized to ferrous ions. At anode, Fe solid is converted into Fe2 positive aqueous plus 2 electrons. Thus, the metal atoms in the lattice pass into the solution as ions, leaving electrons on the metal itself. These electrons move towards the cathode region through the metal. At the cathodes of each cell, the electrons are taken up by the hydrogen ions. Reducing takes place. The H positive ions are obtained either from water or from acidic substances, that is, carbon dioxide in water. Water is converted into H positive plus OH negative. Carbon dioxide plus water is equal to H positive plus HCO3 negative. At cathode, H positive plus electron is equal to hydrogen. The hydrogen atom on the iron surface reduces dissolved oxygen. 4H plus O2 is equal to 2H2O. Therefore, the overall reaction at cathode of different electrochemical cells may be written as 4H positive plus O2 plus 4 electrons is equal to 2H2O. The overall redox reaction may be written in multiplying reaction at cathode equation 1 by 2 and adding Reaction at cathode, equation 2 to equalize number of electrons lost or gained. That is, oxidation half cell. Fe solid is equal to Fe2 positive aqueous plus 2 electrons is multiplied by 2. Reduction half cell, 4H positive plus O2 plus 4 electrons is equal to 2H2O. Overall cell, 2Fe solid plus 4H positive plus O2 is equal to 2Fe2 positive aqueous plus 2H2O. The ferrous ions are oxidized further by atmospheric oxygen to form rust. 4Fe2 positive plus O2 plus 4H2O is equal to 2Fe2O3 plus 8H positive. Fe2O3 plus XH2O is equal to Fe2O3 dot XH2O. It may be noted that salt water accelerates corrosion. This is mainly due to the fact that salt water increases the electrical conduction of electrolytic solution formed of the metal surface. Therefore, rusting becomes more serious problem whereas salt water is present. Prevention of corrosion. The rusting of iron can be prevented or retarded by the methods given below. First, barrier protection. This is one of the simplest method to prevent rusting of iron. In this method, a barrier is placed between iron and atmospheric air. The barrier protection can be achieved by any of the following methods. First, the surface is coated with paint. Second, the surface is protected by applying a thin film of oil or grease. Third, the metal is electroplated with metal like tin, nickel, zinc, chromium, aluminium, etc. For example, many vehicles such as cycles, motors, cars made from iron sheets are protected by rusting by paints. Many iron articles are electroplated with coating of other metals. The electroplating is carried not only for achieving brightness but also to protect from corrosion. Second, sacrificial protection. In this method, iron is protected from rusting by covering it with a layer of a metal more active than iron. This prevents the loss of electrons from iron. The active metal loses electrons in preference to iron and goes into ionic state. Therefore, the covering metal is consumed with time, but as long as it is present on the surface of the iron, the latter is not harmed. This type of process in which rusting of iron is protected is called sacrificial protection. Zinc is commonly used for covering iron surfaces. The process of covering iron with zinc is called galvanization. The galvanized iron materials maintain their luster due to the coating invisible layer of basic zinc carbonate on the zinc film. If some scratches come on the protective zinc film on coated iron, even then iron will not be rusted. This is due to the fact that because of the scratches, both iron and zinc get exposed to oxygen, but zinc undergoes oxidation in preference to iron. This is so because the reduction potential of zinc is higher than the reduction potential of iron. Therefore, zinc undergoes oxidation in preference to iron. However, it may be noted that in case of tin plating, that is tin coating on iron, the film will be effective as long as it is intact. When scratches occur at the coating surface, both the metals are exposed to oxygen, and iron is preferably oxidized and is rusted. This is due to the fact the reduction potential of tin is more than the iron. Thus, iron will be oxidized in preference to tin. Third, electrical protection. This method is used for protecting iron articles which are in contact with water, such as underground water pipes. The article of iron is connected with more active metals like magnesium or zinc. The active metals has lower reduction potential than iron and will lose electrons in preference to iron. For example, magnesium has lower reduction potential than iron. Therefore, magnesium will be oxidized in preference to iron, and therefore it will be protected iron from being rusted. Fourth, using anti-rust solutions. To retard the corrosion of iron, certain anti-rust solutions are used. For example, solutions of alkaline phosphates and alkaline chromates are generally used as anti-rust solutions. Due to the alkaline nature of these solutions, the H-positive ions are removed from the solutions. The rusting is prevented. For example, iron particles are dipped in boiling alkaline sodium phosphate solutions when a protective insoluble sticking film of iron phosphate is formed. Now let's see, what does passivity mean? Passivity refers to a corrosion preventative mechanism whereby an oxidation layer forms a continuous film on a metal surface that prevents further corrosion. Passivity is the loss of electrochemical reactivity, thereby decreasing the corrosion rate of the metal. Passivation results in the barrier of passive film between the metal and the electrolyte. The barrier film can be crystalline or amorphous and can be made of either insulators such as aluminium, titanium, or tantalum, or made of semiconductors such as iron or nickel. Passivation is used on many different engineering alloys such as stainless steel, nickel-based alloys, etc. Passivity is generated by the buildup of the layer of metal oxide on the surface of a metal. In order to provide passivity, this oxide layer must be stable. It is formed by corrosion insoluble components in the immediate environment of the metal. The metal oxide acts as a barrier by separating the metal's surface from its environment and prevents corrosion until the reactants are able to diffuse through the oxide film. This diffusion may take a significant time to occur. Galvanization is a corrosion preventative measure that is based on the occurrization of passivity of steel or iron, in which the substrate is coated with zinc to prevent it from rusting. The process entails immersing clean, oxide-free iron or steel into molten zinc in order to form a zinc passivation coating that is metallurgically bonded to the metal surface. Thank you.